Measures of spread. Okay, here I have two students' scores, so you can see the scores. Now have a look at them carefully and see if you notice anything. Well, obviously without doing any kind of maths, the first thing that we notice is that the first student tends to get more kind of similar scores, whereas the second student is kind of going a little bit up and down. They've got some quite low scores like 50, but also high scores like 90. Now, actually, I've worked out some of the statistics for this, and in fact, the mean, so let's use the proper notation, X bar for student 1 is actually 70. So on average, this student gets 70 marks, and the second student also, the average is 70. But I think you can see that the first student is kind of more consistent. It's getting closer scores together, whereas the student 2, there's a lot of variability in the data. So one of the things we're interested in statistics is this measures of spread, which basically means, can we have a measure or a number that tells us how spread out the data is? Now, we already actually know one of these, and that's the interquartile range. If you remember, interquartile range is the third quartile minus the first quartile. Now, I've also worked it out for these two sets of data, and in fact, let's draw it here, the interquartile range of the first student is actually 9. And interquartile range for the second student is actually 27. So you can actually see there is a lot more spread with the second student's scores than the first. Okay, the first one is a lot more kind of consistent, whereas the second student's are kind of going up and down a bit. So it's debatable, which is the best student. Probably student 1 is the best student. On the other hand, this student 2 kind of got a 90% here, so maybe if they worked a bit better, they could get higher scores. Who knows? Okay, now the problem with the interquartile range is that it doesn't use all of the values. Okay, we want to have a kind of a better measure of the spread of a data, which takes into account all of the numbers in the data set. So the measure we tend to use is this standard deviation. So I'm going to do an example. So now before we work out standard deviation, we have to work out this thing called variation, which I'll explain first. The connection between the two is quite simple. So I'm going to take some data. So we're going to use these numbers: 2, 5, 0, 8, 4, and 5. Okay. Now, what we're looking for is, in this case, is first of all, what is the mean? Now, I've already worked out the mean. The mean is actually 4. Okay. So what we're going to do is we're going to work out how far each of the points are, or each of the numbers are from the mean. Now, this is called deviation, because the word deviation means kind of difference from what's kind of usual. So in this case, we're taking the mean as being kind of like the normal number, and we're going to work out what is the difference between each of our numbers and the mean. Okay, so the way we're going to do that is we're going to take our number and we're going to subtract the mean to find the difference. So obviously 2 take away 4 minus 2. 5 take away 4, 1. Okay, so this is showing that the first number is 2 below the mean. The second number, 5, is 1 above the mean. 0 minus 4, minus 4. 8 minus 4, 4. 4 minus 4, 0. So exactly the same as the mean. So it has a deviation of 0. And 5 take away 4 is 1. Now, one thing that we could do is kind of average these numbers and find the average deviation. Now, the problem with that is if you add all these numbers up, you will notice that all of these numbers add up to 0, and they'll always add up to 0, so it kind of doesn't really help us. So what we're going to do is, well, one thing you can do is ignore the signs, so just do it as a difference and not include the negative sign, so make everything positive. And that actually is something in statistics, but it's not really used. So what we're going to do is, to get rid of the negatives, another thing that we can do is to square the deviations. That will definitely get rid of all the negative signs for us. Okay, so we're going to square the deviation. So this will be 4, 1, 16, 16. I'm just squaring all the numbers. 0 squared 0, 1 squared 1. Now, this thing called the variance is the average of the deviations squared. So in other words, we're going to add all the deviations together and we are going to average them. So there are 6 numbers. So it's the average of the squares of the deviations. So I'll just work that out. So that's 38, and then we're going to divide by 6. Okay, 6 on the third. Okay, so the variance of this data is 6 1/3. Now, the standard deviation is the square root of the variance. So in this case, I'm just going to square root 6 1/3, and it's going to give me 2.52. So the next question is, what do we do with this number 2.52? Well, really we need to have another set of data to compare it with. Really, on its own it's kind of not got a lot of meaning, but it's a measure of how spread out this data is. Now, also want to look at the formula for this. So let's look at what we did. So standard deviation, so it's the square root of. Now, how did we work out the variance? Well, what we did was for each number, so we use xi for that. So xi, we took away the mean, so x bar. For each number, we did that and we squared the result. And what we did, we summed all of the answers for each bit of data. In this case, we would have x1, x2, x3, x4, x5 and x6. We would do it for each of those numbers. And once we'd added all those up, we divided by n. So this should be divided by n. So this is a formula for one formula for standard deviation that you may see. Now, the notation for standard deviation, there are 2 different ones, unfortunately. One for the population and one for when you have got a sample. Now, let's assume that this is a sample, so we would use the notation SN, okay, if that was a sample. If it's a population, we use sigma, okay, which I'll show you later. So that's the first method. Now, the second method gives you exactly the same results, but it's just a slightly different formula. If you're interested in the proof of this, I've got it in another video. It's optional. So the formula is this. Now, this is actually a slightly easier formula to use, but it always gives the same answers. So let's do the same example. the same set of data. Okay, so what it means is standard deviation. So what we're going to do is we're going to sum xi squared. Xi means the data, basically, the data numbers. So we don't have to find any differences this time. We can just square all the numbers. So it's going to be 2 squared plus 5 squared plus 0 squared plus, and all divided by 6. And then we're going to take off the mean squared, and the mean was 4. So basically we just put this into a calculator. So then I've done this bit, and then we take away 4 squared, so take away 16. And you can see I've got the same result. Yeah, square root of 6 1/3. Okay, which was 2.52. It's a slightly easier formula to use, especially if you have a mean which is not a nice number. It's much easier to use this second formula. Okay, now also we need to know how to use the calculator for this. So let me show you quickly. It's exactly the same as when we were finding the mean, actually. Go to Stat, Edit. I've already put the numbers in here. So what I've done is I've put student 1, the original student 1, into list 1, and student 2 into list 2. So go to Stat, Calc, and we need this number 1. So it's asking where is the data. The data is in, the first student is in list 1. So let's do the first student first. So list 1. Frequency list we'll do later. You just leave that blank. So this will just produce the statistics for student 1. So you can see the average was 70. And the one we're interested in is the sigma x, the bottom one, 6.02. Okay. So this is the standard deviation, the bottom one. Okay. You may need this SX thing. If you're interested, I can explain it to you. But at the moment, we just need this bottom one. So it's 6.02 for student 1. So let's do it now. For student 2, we would just need to go back to Stat. Go back to 1 bar stats, and this time change it to list 2. So second 2, change it to list 2. It will now work out the statistics for list 2. Again, mean is 70. This time standard deviation is 14.7. So student 2, 14.7. So now we've got a comparison which uses all of the data, and you can see that student 2 has a lot more variation, there's a lot more spread in the data. It's more than twice the variation of the first student. Okay, one last thing is to be able to work out the standard deviation when the data is in a frequency table. So in that case, go to Stat, Edit. We need to clear the lists, so go up to the top and press Clear, Enter. So highlight list 2, press Clear and Enter. And then we type in, so this time in this case the grades, this was IB grades I guess, goes into list 1, so 3. And the frequency into list 2. Okay, and then we press Stat, Calc. This time it wants to know that the list is where the numbers are, okay, the grades. So in this case, this needs to be list 1. And this time we have a frequency list because we basically have 2 grade 3s, 6 grade 4s, 8 grade 5s, and so on. So this needs to be list 2. And now we calculate, and you can see it's telling us that the mean is 5.04, so the average grade was that, and the standard deviation is 1.14. So that's how you work out the standard deviation from a frequency table.